Machine is basically a device which is used to provide different types of action. What are the different types of action? And suppose you want to lift a heavy load. Okay, you want to lift a heavy load. So for that you need a machine because the something which cannot be done by our own. Okay, so then only I should need a device which is called the machine. So let us say I want to lift a heavy load. So for that I should go for a machine. So machine is basically doing the lifting of the load. Or in some situation I want to reverse the direction of force. Okay. Suppose if I am applying a force in this direction and I want to apply this force, let us say I am applying a force of A in the forward direction. But I need the force to be reversed in the opposite direction. That means I want to get another kind of force in the opposite direction. So whenever I want to change the direction of force or change the direction of load like these things, so I should go for a machine. Okay, so machine is basically a useful component in our daily life. In every aspect, I should use the different types of machines. So depending on the requirement, the classification will be different. Okay. So first is, as I said, that in lifting a heavy load. Let us say there is a car. So car is quite heavy. So you want to lift the car with the help of a machine. So this machine is known as the jack. This is the known as jack. So I want to lift the entire car using the jack, screw jack mechanism. So for that I should apply a load or force on this jack so that jack can lift the load. Okay, so here I am putting a drill machine, so which is basically rotating this jack. Okay, so once I rotate this jack, so the jack will expand and ultimately it will lift the car. Okay, so the lifting of the car that cannot be done manually. Okay, if I use my hand only to lift the car, it will be quite difficult. Okay, so for that I should need a machine. So machine is doing the same purpose, so the lifting of the load instead of I am using the power. Okay, I am using only one machine which is acting as a device which is basically used as a force multiplier. Why force multiplier? Because as a input, here I am giving a, let us say, F1 amount of force. As an input, I am giving F1 amount of force, but F1 amount of force that I am applying at the input is not sufficient to raise the entire load. So for that, I should need a force of, let us say, F2. Okay, and clearly F2 is more than F1. Okay, that means F2 is more than F1, and it is also the restriction that I cannot apply the F2 amount of force. So for that I am using one machine. So machine is applying the same force, F1 amount of force, which has to be converted into F2. Okay, that means this jack mechanism or the jack machine is basically taking F1 as input of the force and multiply to produce the F. That means it is acting as a force multiplier. Let us say I am giving one example. Let us say F1 is 10 Newton. But 10 Newton is not sufficient to raise that power. So for that, let us say I need a F2 value which is equal to, let us say, 80 Newton. Okay. That means 10 Newton has to be multiplied by 80. Multiplied by 8 so that I can get the 80 Newton value. So that means this particular device or that is jack is basically acting as a force multiplier. Okay. The force multiplier is one part of the use of the machine where I am using the multiplication. The force has to be multiplied so that input force has to be increased. Input force is increased. Now, second application may be the changing the direction of the pointer application. Okay. In changing the pointer application of the effort to convenient. Okay. Let us say here this is a chain and sprocket mechanism. It's called a chain. So sprocket and chain. Now with this machine, what I am doing, I am applying a force or input of force. Let us say at this point I am giving the input. Here the input of force is given. Okay. But that input of force is changed to some other point. Okay. What is that point? That is this point. Okay. So whenever I want to change the point of input to output, I am not able to get the same output from the same point. I am giving the input at this point. and correspondingly I'm getting the output from some other point. That means now I change the point of application. So in that situation, I should go for the use of machine. So this is another kind of machine. So the utility is different. Here I am not using the multiplier concept. The force is not multiplied. Here using the defined concept. Now go for the some other situation where I want to use a machine which is basically useful for the change in the direction of the effort. Whenever I want to lift a heavy load, I am using a pulley mechanism. So let us say this is the pulley part. So this is called fixed pulley. The pulley is fixed at this position. So here at this point I am applying the load. So here let us say I want to lift a load. So a bucket of water has to lift it. So that means I have to apply the force in this direction. But as the input I am giving the effort over here, which is in the other direction. Okay. A lift has to be elevated in the opposite direction. So that means where the direction of the effort to the convenient direction, because it is convenient to apply the effort in the downward direction. So I am applying the effort in the downward direction, and that is basically changed to lift the load in the upward direction. Okay. So this is the another utility of the machine. Now, to gain in speed, that is the velocity multiplier. Okay. That means in this situation, if you go through the scissor is also a kind of machine. So once I am applying the force, let us say this is the scissor point. Okay. I am applying the force in this position. So this is the effort. Now with this effort, it is initially it is difficult to cut the paper. Once I start the cutting process, then it is easier to move. Okay. So actually what is happening, the machine is gaining the speed. Or gaining speed, there is greater movement of a load by a smaller movement of it. Means if I apply a small force over here, that is small displacement, so this fulcrum point will be shifted larger. Okay. So that means it is basically used as to increase the speed, gaining speed. Okay. So there are four basic utility of machine. Either I can go for a machine which is used to lift a heavy load, that means it is acting as a force load. Okay. Or I can use a particular machine which is basically transfer the point of application of force. Right? In this particular situation, here I am applying the input at point number 1, and at point 2 I am getting the output. Both input and output are not the same point. Okay, that means I have to get at output in some other defined location. Okay, that means whenever I want to change that location, that means I should go for a machine. In changing the direction of the effort, whenever I want to change the direction of the effort to a convenient direction again. So then also I should go for the machine. Or lastly, it is called the velocity multiplier or the gaining speed. So these are the four basic mechanism or four basic utility of any kind of machine. Okay. So depending on that, let us say this is another kind of machine. This is called a gearbox machine or mechanism, where there are different types of gears are there. Different types of gears are there. So if I say this is the input part, so as an input I am giving some kind of energy to run the red colored gear. So once I run this red colored gear, so it will automatically rotate the blue color. Okay. So energy is being transferred from red to blue. Now in turn of the blue is now connected to the green. Blue is now connected to the green. So ultimately green will also rotate. Okay. So here I am getting the output. So depending on the speed, either I should go for increase in speed. That means the green colored gear may rotate at a larger speed. So depending on the requirement, the speed may be increased or speed may be decreased. But only thing, one important point regarding this mechanism is that here I am transferring the input from one point to the other. So as an input, I am giving the energy to this gear number 1. Gradually, the energy or the power has been transferred from one gear to the other. Okay. So this is the idea of the mechanism or any kind of machine. Similarly, this is the another situation where several sorts of gears are there, but the gears are individually rotating. Gears are individually rotating. So as the input, either I can give the input over here and I want to get the output from this position. Okay. So whenever I want to transfer the energy or transfer the work from one point to the other point, further I should need a machine. For that, I should need a machine. Now, the formal definition of machine: a machine is a device by which we can either overcome a large resistive force. So that large resistive force that I want to overcome is called the load. At some point by applying a small force, because as a input I always want to give a small amount of force. Okay, it's called the effort. The effort is basically the amount of force that I am applying, okay, to the machine, and machine is basically used to lift the load. So machine output power, output load, output energy, basically the load part. That means that much amount of force that we are getting out of this. Okay, at a convenient point and in a desired direction. So both of these two have to be satisfied. I have to apply the force at a particular convenient point, not any other point. And also I want to get the proper direction. So by which we can obtain a gain in speed. By which we can obtain a gain in speed. So machine cannot be used as a force multiplier as well as a speed multiplier. That means if I go for one particular machine which is used to lift a heavy load, that is basically used as a force multiplier. So force multiplier, that particular machine cannot be used simultaneously to weight the velocity multiplier. Okay. So both cannot be achieved simultaneously. At a point, at a single point, once I'm getting the force multiplier, so then that means I'm getting the speed multiplier in some other situation. Okay, both are not to be achieved in the same point. Now these are the very important definition or parameters related to any kind of machine. First one is the load. So I have already said the load is nothing but the force that you have to work. Okay, so machine has to apply some kind of force. That force is the load that you have to work. Resistive force obviously. Effort is the amount of force that you are applying. Applied to the machine to overcome this load. So I am applying the effort, and in turn, machine is producing the load. Okay. So ratio of these two is called the mechanical activity. Load by effort. So load by effort, that means how much amount of load that I want to elevate or I want to lift. And for that, how much amount of force that I am applying, that is called the effort. So load by effort ratio is called the mechanical advantage. Load by effort ratio is called the mechanical advantage. Now, this mechanical advantage is basically a term which is basically defined for the force multiplier situation. Whenever I want to get a machine which is basically acting as a force multiplier, that means let us say I am applying a 10 Newton of force over here, I am getting 8 Newton of force over there. That means 10 is multiplied by 8. So that 8 number is acting as a mechanical advantage. Ratio load by. Now similar to this, there is another ratio that is called the velocity ratio. Another ratio is the velocity ratio. So velocity ratio is nothing but the velocity of effort divided by velocity of load. So whenever I am applying, so whenever I go for speed, so velocity of load means, let us say this is a machine. Okay, in this situation, if I want to calculate the velocity of load, so what is the velocity of load? Load is nothing but the displacement. Displacement is how much? Displacement of the load. Right? Displacement of the load per unit time. Let us say I am saying displacement of the load. So in this situation, I am applying a force. I am applying a force. The load is being elevated by 100 millimeters. Yes. Initially, the car is on the ground. Let us say the car. Okay. Once you apply a force in this direction, that is the effort you are applying. So this point is elevated by a distance of 100 millimeters. Okay. So this 100 millimeter is nothing but the displacement of the load. Similarly, I am lifting my hand by a distance of 300 millimeters. So 300 millimeters is nothing but the displacement of the effort end. Okay. So velocity effort is nothing but the displacement and displacement effort end per unit time. Similarly, displacement of load end per unit time. Okay. So ultimately, it gives a ratio of displacement by effort divided by displacement of load end. So displacement effort end divided by displacement of load end, that will give the ratio of velocity ratio. So velocity ratio is a ratio which is often defined whenever I want to get a machine which is acting as a velocity multiplier. Okay. Velocity multiplier. So it is the ratio of displacement of effort end divided by displacement of load end. Hmm. Now, input. What is input? Input is the work done on the machine. Work done on the machine. So, what I am giving as input, that is our input part. Input part. So, as an input, I am applying the effort. As an input, I am applying the effort. So, basically, it is the effort into displacement of effort. And I say that is the work input. This much amount of work I am giving as input. Similarly, load output. Work output is basically the work done on the load, that is the load part into displacement of load. Okay. So work input is the work done by the effort and the work done by the load. So into displacement. Okay. So now if I take the ratio, if I take this two ratio, that is input by output, that gives the efficiency. Input by output is the efficiency. So if I take efficiency, so efficiency should be equals to work input hereby work output. Okay. Multiplied by 100%. So always efficiency is 100, less than 100% because input is less, output is sorry, not input by output, output by input. No? So as a output, how much amount of work that I am getting, work output, thereby working. Okay. So that ratio is the efficiency. Efficiency machine is the ratio of the work done on the load. On the load means output divided by input part, that is by the effort part. Okay. So this ratio will give the value of efficiency. Now, so when energy is supplied to a machine by applying the effort, it overcomes the load by doing some useful work on. Every machine should work on this principle. That means whenever I am applying some kind of force, that means as a effort I am applying the force, so that effort is doing some kind of work. That effort is doing some kind of work because the displacement is there of the effort and correspondingly the load is there and that is also doing some kind of work. Okay. So this ratio is basically has to be maintained as a efficiency of the machine, and that is the basic action of the principle of any kind of machine. So any machine work on this principle that some amount of energy has to be supplied to the machine in the form of okay to overcome the load. Now regarding the ideal machine. Now, whenever I am saying ideal machine, that means the ideal machine is that in which there is no loss of energy. Okay, whatever the energy that I am giving as an input, fully utilizes the output part. Okay, so for this machine, everything is 100%. So these machines are basically the ideal machines for which the efficiency is 100%. But it is an actual machine. In actual machine, the output energy is always less than the input. So whatever the amount of energy that as the input I am giving, I am not getting the same out. Why? Because there is some kind of loss. So there are three types of loss are present. There is a moving part in any machine. There are some moving parts. Okay, so whenever there are moving parts, in order to move those parts, I have to overcome the friction. So there must be some kind of loss. There is a string. It is not particularly elastic. String, and its different parts are not particularly rigid. So, because of this reason, mainly, so there is a deviation from the ideal to the actual. So, whenever I go for the actual machine, that means Windows machine, the efficiency value is less than 100. So, it is not equal to 100%. Because of some kind of losses are involved. Now, so far we define all the parameters. Now, based on the definition, I want to get a relation between the efficiency, mechanical advantage, and basic ratio. So, the efficiency is basically, the efficiency is defined as the output by input. This is the efficiency value. Now, what is output? Output is basically the work done by the load. Work done by the load. So, load into displacement of load and hereby work done by the input or the work done by effort is effort into displacement effort and okay. That means what I am getting? I am getting the load by effort is one ratio multiplied by 1 by d by L. Okay. Now load by effort is what? Load by effort is mechanical advantage. Is a mechanical advantage. And D by L is the velocity ratio. Okay. So mechanical advantage by velocity ratio, that is the efficiency. Hmm. So from this, I am getting the relation that eta into VR, that should be equals to M. Hmm. That should be equals to M. Hmm. Now, so that is the relation between the mechanical advantage, velocity ratio, and efficiency. Hmm. So from this, it is quite clear that mechanical advantage of a machine is basically the product of eta and VR. Eta and VR. So for an ideal machine, if I go for the ideal machine, so for ideal machine, eta is equals to 100%. No, eta is equals to 100%. So for that ideal machine, only we can say that MA is equals to VR for ideal machine. But all machines are not ideal. So they are the actual, the real machine. So in real machine, so efficiency is always less than equals to 1. Less than 1. So if eta is less than 1, then what we can say, the MA is less than VR. Will not equal. So either they will be equal or they are not equal. So theoretically, what you can say, if the efficiency is less than 1, then MA is less than VR. That is correct. But if I say efficiency is equals to 1, then only MA and VR both are equal, and which is only valid for the ideal machine. Which is only valid for the ideal machine. Okay. Now come for the another type of machine called a lever. So lever is basically a device which is rigid, straight, or bent bar, which is capable of turning about a fixed axis. Okay, so there is one axis about which it can rotate. So that fixed axis is called the fulcrum. Fixed axis is called the fulcrum. So depending on this lever, so there are maybe, depending on the position of the fulcrum, the lever may be of different types. So let us say this is the class 1 lever. So this is the position of the fulcrum. Class 2 lever, fulcrum is at the end position. Class 3 lever, fulcrum is the end position, but only difference is the load and effort are at different locations. Okay. So class 1 is the particular lever where fulcrum is the middle position, and you are applying load on one end, and you are applying effort at one end, and you are lifting the load from the other end. So the distance of effort from the fulcrum is called the effort. Let us say it is called the LE. It is a load arm LL. Okay. So from the principle of lever mechanism, what I can say, E into LE, that number should be L into LL. Got it? Why? Because principal moment. About the fulcrum position, net moment should be equal to 0. One moment is given by E, another moment is given by L. So total moment should be equal to 0. So moment of capital E is equal to E into LE, and moment of L is equal to L into LL. So it should be correct. Same logic goes for the class 2 lever. Same logic. So load into load arm, effort into effort. Now in class 2 lever, what happens? The effort arm is more than the load. Effort arm is more than the load arm. So depending on that, effort arm is more than load arm. So always, what you can say that mechanical advantage, or let us say, in the second situation, if I write L by E ratio, L by E ratio, L by E ratio should be equal to how much? FA by FB. FA by FB. Now, it is always FA is greater than FB. In the class 2 lever, FA is greater than FB. FA is always greater than FB. Whereas, class 3 lever, FA is less than FB. In this situation, FA is less than FB. So, L by E ratio or the mechanical advantage is always greater than 1. Mechanical advantage is always greater than 1. Here, mechanical advantage is always less than 1. Okay. And depending on the value of FA and FB in the class 1 lever, either it will be equals to 1 or less than 1 or greater than. Okay. So that means that is the position of the effort, the fulcrum. Where the fulcrum is positioned, depending on that, I can say in some class of some set of machines, the LA number or FA number is more than FB. In some such situation, FA is equal to FB. Okay, so all three are possible. In this first case, class 1 lever, so depending on the value of FA and FB, the E by L by E ratio, L by E ratio that is equals to FA by FB, that is also true. But what we can conclude that this L by E ratio or the mechanical advantage may be greater than 1, maybe less than 1, maybe equals to 1. Definitely I cannot say. But for class 2 and class 3, either MA is greater than 1 or MA is less than 1. So that is the, if effort arm is equals to load arm, MA is 1. Effort arm is greater than 1, greater than load arm, that means the mechanical advantage is greater than 1. Or effort arm is less than load arm, that means mechanical advantage is less than 1. Okay. So obviously the mechanical advantage of a lever can be increased by increasing the length. If I want to get the mechanical advantage on the higher side, so I have to increase the arm length. Once I increase the arm length, depending on that, the mechanical advantage will also increase. Now depending on the, now come to the classification. So this is the class 1 lever. Class 1 lever is the fulcrum has to be between the effort and the load. First situation. Where the fulcrum is in this situation, always, so this is the fulcrum position. One end should be effort end, another should be load. So depending on the distance between the E and F, mechanical advantage will change. Okay. So in a seesaw, so if I say these are positioned in the same distance, let us say these are EF number, these are LF number. So depending on the EF and LF value, so whether the mechanical advantage will be 1, greater than 1, less than 1 or equals to 1, it depends. Okay. It depends. But one thing is sure that every time the fulcrum is positioned at the middle position. Got it? Now these are the different types of example of class 1 lever. So all the situation is that the fulcrum is at the middle. Okay. So in each and every situation, fulcrum has to be middle point. About the fulcrum, on one side has to be load, another side should be the effort arm. Now come to the class 1 lever. The mechanical advantage and velocity ratio can have any value. Why? Because depending on the position of the fulcrum and depending on the effort and load arm, so the length, this distance and this distance may be different. Okay. So depending on that, the mechanical advantage may be greater than 1, maybe less than 1, or maybe equals to 1. All three are possible. All three are possible. Now come to the class 2 lever. Class 2 lever fulcrum goes to one end. One end, the fulcrum is. At the end point, the fulcrum has to be there. And effort is on the other end. One end is fulcrum, another end is effort. In between, the load has to be there. Effort is on the one end, fulcrum is on the other end, and in between the load is there. That is a class 2 lever. So in this class 2 lever, what I can say that the load end, effort arm, effort arm is always more than the load arm. It is always true. That effort arm, that means the FE number is always greater than the FL number. So load end is on the shorter side compared to the effort end. I think mechanical advantage is going to be more than 1. Mechanical ratio of class 2 are always more than 1. Always. It is always true. But that cannot be commented for the class 1 lever. So for class 2 lever, fulcrum is at the end point. Effort arm is at the end point. Load is in between. Okay. So L by E ratio, that is the mechanical advantage. That should be equals to FE by FL. We always greater than 1. That means I can conclude directly that mechanical advantage is always greater than equals to 1. Greater than 1. It cannot be equals to 1. Or it cannot be less than 1. But that is not the third lever. For the class 3 lever, mechanical advantage is less than 1. Why? Because in this situation, only difference is that fulcrum is at the end point. Hmm. Now, instead of low effort, the load will come at the other end. So, in between the effort is there. So, this length is shorter now. Effort and length is shorter. So, that means the mechanical advantage is going to be less than 1. Mechanical advantage is going to be less than 1. So, this is how the three different classical levers are there. Okay. Now, try to do this one. No, no. What you are saying, the load end and effort end both are equal. Why? AB is 2 meter and FA is 20. Why mechanical advantage is 1? Mechanical advantage is not 1, no? Mechanical advantage. So, what is this distance? AB is 2 meter and FA is 20 centimeter. Means this much length is 200 minus 20 means 180 centimeter. Can I say it? And this is 20 centimeter. Okay. So, mechanical advantage equals to L by E, and that is equals to 180 by 20, 9. Mechanical advantage is 9. Okay. And you are asked to calculate the calculate the mechanical advantage, calculate the effort. Load is given as 18 kg. 18 kg is the load. So L by E ratio that is got at 9. Okay. L is 18 by E equals to 9. So E is 2 kg. Part B. So in the part B, you are asked to calculate the mechanical advantage. What is the representation of mechanical advantage? L by E. Nah. So that is ratio of load by effort, and that should be equals to effort arm divided by load arm. 180 is how much? Effort arm. Distance of effort from the fulcrum. And 20 is the load arm. What is the distance? That is 20. So that ratio is what the mechanical advantage. That comes to 9. Okay. So in order to lift this load 18 kg force, you have to apply a effort of 2 kg force. Okay. Now do this. No, why? 1 by 3. It is the position of fulcrum, na? Here we are applying the effort. Here there is a load. Okay. So load length is 20. Effort length is 20 plus 40 and 60. Okay. So mechanical advantage because load by effort. Load by effort. That should be equals to how much? Effort arm. Means Fe divided by Fl. Fe is how much? 40 plus 20. 60. Here Fl is how much? 20. That is the mechanical advantage. Now, the minimum effort is got to keep the leg just off the ground. So load is how much? So here is another running a load of 30, no, not 30, 30 plus 50. Mass is 50 kg carrying a load of this one. So total amount of load is 30 plus 15, 45. So you are asked to calculate what is the E number. Okay, so L by E equals to 3. That is equal to 45 by E. Nah. So E is 15. Understood? So this is the minimum amount of force that you want to apply at the effort side. Merely the load can be lifted. What is the total load? So the load of the 15 kg is there. That is the entire mass of the wheelbar. And along with that, some amount of it is carrying something. Okay. So that mass is 30. So you have to add these two numbers. So that much amount of load you have to leave. That is 45. Correspondingly, you are applying E. Okay. Now come to the concept of another machine called the pulley. Hmm. So pulley is basically a device. So either it may be a simple pulley, which is a fixed pulley. So fixed pulley means this is the fixed part. It is a fixed pulley. Hmm. Fixed pulley. On this pulley, the rope is there. On this pulley, the rope is there. So once I allow the rope to pass on this pulley, so now let us say I am saying this is a rope. So if I pull this part in the downward direction, then essentially this part will move upward. Yeah. So one part is moving downward, one end is of the pulley moving downward, means other end of the pulley moving upward, and that is always true for the fixed pulley. But that doesn't mean that for free pulley it is also same. So free pulley means the pulley can move. So fixed pulley means the pulleys are not moving. So in that situation, if I pull one end, let us take the point A is pulled by a distance of x. If I pull this distance by A, then the end B will also lifted by the same distance x. Okay. So it is true for the fixed pulley. Understood? So single fixed pulley. So pulley which has its own axis of rotation fixed in position is called the fixed pulley. So here, this is the fixed pulley. This is the fixed pulley. So whether you are applying a force on the string, so whatever the situation, the load is being lifted up. Load is being lifted up, but there is no change in the position of the pulley. So every time the pulley is being fixed at this position. There is a fixed position of the pulley. So pulley which has its own axis of rotation fixed in a position is called the fixed pulley. So due to the rotation of the pulley, the direction is not going to be changed. Direction is not going to be changed. So for a single fixed pulley, what you can say that if I apply the load, if I apply a force of E at this position, okay, here I am pulling this in with the E force. Similarly, the load will be lifted in this upward direction. Load will be lifted in the upward direction. So since this the string has the tension same throughout, so can I say the L number that has been lifted is nothing but the amount of effort that I am applying. So in this situation, L equals to E. And if L equals to E, then mechanical advantage is always equals to 1. Mechanical advantage is always equals to 1. It is not going to change. So mechanical advantage is always equals to 1. L equals to E. For a single fixed pulley. For a single fixed pulley. Got it? Now single movable pulley. So pulley whose axis rotation is movable. Okay. Now in this situation there are two pulleys. So this pulley P1 is fixed pulley and P2 is the movable pulley. Okay, so P2 can move up and down. So that means whenever the pulley is moving up and down, that means the pulley is going to change its position. Pulley is not at the fixed position. That means it is called a movable pulley. It is the system of movable. So in movable pulley, depending on the distance traveled, the effort or load will be different. Effort or load will be different. Let's say this is a situation where this is the load part. This is the load part, and you are applying effort on this position. So in this situation, what happens? If I say this is a string, so on this string the tension will be T over here or the T over there. So for this string, the tension will be how much? 2T then? No, 2T. So if I say that once I apply an effort at this position, so displacement is in the upward direction. Similarly, load is being lifted in the upward direction also. Okay, load is being lifted in the upward direction. So in this situation, A equals to 2T, A equals to 2T, and E equals to T. Nah, E equals to T. So if I simplify this, that means what I can say, load equals to 2 times C. Okay. Or L by E ratio is how much? 2. The mechanical advantage is 2. Okay. That means mechanical advantage is equals to 2. So in the first situation, when the pulley is fixed to 1, mechanical advantage is equals to 1. And here, one fixed pulley, another moving pulley, mechanical advantage is equals to 2. So it depends on the number of pulleys. It depends on the number of pulleys. More the number of pulleys, mechanical advantage is going to be increased. Then for the combination of pulleys. So whenever there are different types of pulleys are there attached with one another, called the extra combination. When a heavy load is to be lifted, so then only I should go for a combination of. Yeah. So there are two types of combination that are possible. One fixed pulley and several movable. Using several pulleys in two blocks. Upper block and lower block. Because the block and tackle system. Okay. So first we discuss the first setup. This is the first setup. One fixed pulley. This is the one fixed pulley. This is the, let us say, P1 pulley. That is the fixed one. All the other pulleys, 3 pulleys are movable pulley. Okay. Now at this, the fixed pulley end point you are pulling. That means here you are applying the effort. Okay. And the last pulley is connected with the load. Last pulley is connected with the load. Okay. So on the effort end, if I say tension is T3, so that means here T3, here also T3, here also T3. So now what is the relation T2? T2 should be equal to 2 times T3 then. No, because T2 is connected with 2 times of T3. So here it is T2, here is T2, here is T1. So what is T1? 2 T2. 2 T2 means 4 T3. Okay, 4 T3. It is 4 T3, 4 L becomes 2 T1. So 2 T1. So what I am doing, I am at the one end of the fixed pulley, I am applying the effort. Okay. Now consider this is the string. On this string the tension remains same. Okay. What is the tension? T3, T3, T3. And there is another string. There is another string like this. On this string again the tension is T2, T2, T2. The last string is there, another string is there. There is another string. On this string the tension will be different. Okay. On the yellow string the tension is T3. So that means on the blue string it should be T3. Okay. So on the blue T2 means on the bar it should be T2. Okay. Like this way I am adding the tension. So ultimately what I am getting L should be equal to 2T1 and 2T1 equals to 8T3. No, 8T3. So this is the load part that you are getting. And effort is how much? Effort is T3. Okay, effort is T3. So mechanical advantage that is equal to L by E ratio. L is how much? L is 8T3. L by T3 means 8. Okay. Why this 8 number? Because there are 3 moving pulleys. Yeah. So it can also be a 2 3 for N. What is N? N equals to 3. What is it? 3 is the number of moving pulleys. One single fixed pulley and 3 other moving pulleys are there. So in that situation, mechanical advantage is coming to the 21. So as the number of moving pulleys are increased, if I go for 3 or 4 moving pulleys, so that means the mechanical advantage is going to be increased. That means if they apply a small amount of effort, I can lift a large amount of load. Okay. So now there is a second argument is that, so here there are two blocks. Here there are two block system. What is that? So in the block system, let us say in the first situation, so these are the connection is like this. One end which is being connected with the effort end. So the same single string is passing over different pulleys. Okay. So same single string passes over the different pulleys. So that means tension in each and every system will remain same. Okay. Tension remains same. So here, so E if I say T, the load becomes how much? Load is here T, here T, here T. How many T's are there? 6. Not 6. There are 6. T, T, T. 3, 4, 5. 5 na? Hmm? Yes. The connected with the load part. Or connected with the load part. Okay. Now, for this load, how many number of pulleys are there? 5 pulleys are there. Okay. Since I am using one single string process with different pulleys, so load should be equal to 5T. Got it? Load should be equal to 5T. And effort is equal to T. So mechanical advantage is 5. Yeah, mechanical advantage is 5. In the second situation, number of pulleys are 4. Hmm. So L should be equal to 4T. So mechanical advantage is equal to 4. So that depends on the number of pulleys. That depends on the number of pulleys. Got it? So number of pulleys in total system, not the upper block or lower block. If I say the mechanical advantage is equal to 4, the 4 is the total number of pulleys. Now out of 4, the distribution may be upper 1 3, lower 1 1, or upper 1, lower 1, both are 2 2. Here upper block is 2, so there are 2 pulleys in the upper block and 2 pulleys in the lower block. Okay. So dependency is depending on the number of pulleys. How many pulleys are there? More number of pulleys means more is the mechanical advantage. Okay. The effect of weight. If I add, so in this situation, whenever I am calculating the load part, so only I am taking care about the tension, not considering the effect of the weight. So if I say weight is there, weight is there. So for this situation, weight of pulleys are considered. So effort is always equal to T. Here I am not changing this. Okay. Now what about the load? So you have to calculate the load plus weight of the pulley should be equals to total number of pulleys into tension. Got it? So L should be in the earlier situation, N should be how much? N. Now I want to apply W that. So not only I have to leave the load, but also we have to consider the weight of the each pulley. L plus W should be equals to NT. So mechanical advantage, so L becomes how much? NT minus W. Yeah. So in this situation, mechanical advantage becomes how much? Mechanical advantage is equals to L by E ratio. That should be equals to NT minus W divided by T. Na? T. Or what we can say, N minus W by T. W by T. That is the mechanical advantage. Now what is T? T is the effort. Or in the other way, you can write N number of pulleys minus weight divided by effort. In this situation, the mechanical advantage is less than. Whenever you consider the effect of weight, so advantage is equals to N. In the earlier situation, mechanical advantage is becoming 4. Why? Because total number of pulleys are there. So that mechanical advantage is equals to N. N is the total number of pulleys. Okay. But in the second situation, when you consider the effect of weight of each pulley, now the mechanical advantage is less than the N, minus something. Okay. What is that something? That is the weight of each pulley, total weight divided by effort. Okay. So that will be correct value of the mechanical advantage. Okay. So that will end this. Okay. Now your task is to solve the question. And if you have any doubt, ask me. So probably I will take another class tomorrow or day after tomorrow. Maybe Sunday or maybe Saturday. Okay. I'll confirm. Okay. Bye then.